Now that you have learned how to create arrays, we can also do mathematical operations with arrays, and this is very, very important. That's why array is normally regarded as the workhorse of Python, because you can transform all the elements of an array in one single step. And the best way to see this is using examples. So let's create a simple array and say number. So I've created a variable name called number, and then I'm gonna use the linspace function to create a random array. So this my array will start at -1 and then stop at 5, and I want 7 elements within that. So let me just create that array, and you can see I've created my array. These are the elements inside the array. So to do mathematical operations in this, let's give an example of multiplying this array by number 5. So if you do that, you can see it has multiplied each element of the array and gave us the answer here. So 5 multiplied by -1 is -5. 5 multiplied by 0, 0. 5 by 1, 5. 5 by 2, 10. 5 by 3, 15. Like that until the last element. And this is not limited to addition. We can also do division. Let's divide by 2. You can see equally the same thing. 2 divided by -1 is -0.5 by 0, like that, by 1.5. Same goes, let's raise this number to the power of 3, and you have your answer here. We can equally do subtract the number 20 from the number and see the answer. So in other words, you can literally carry out any operation using mathematical or using arrays, and this is very, very important because one single operation will change each individual element of array, and this is very useful for data analysis or even for people who are into simulation and engineering applications. So arrays can also be two-dimensional, in other words, kind of a matrix form. And to do this, let's create a simple array. By the way, I can say array 2d. Let's call a variable name array 2d. And you can always create an array using, I didn't show you this, but you can just say nrp and have a list, and within it have square brackets. So, and then have the first elements of that array. So just follow this, 2, 3. So that is the first element, which is equivalent to the first row in matrices. And then equally 4, 5, 6. If you do this and just do array 2d and run it, so you're gonna have a two-dimensional array. So these are the first elements 1, 2, 3, which is this first square bracket, and then the second element 3, 5, 6 is the third square bracket. And I can have a second array 2. I'll do the same thing, np.array, but for the purpose of time, let me just copy this and change the values, each one to 2, 2, 2, 2, and I can multiply the two arrays. So let me make sure I print it, and then I can multiply the two arrays, the first one being this multiplied by this to give me, so you can see the answer that we are having there. So each of these elements have been multiplied by the elements here to give me the answer. So unlike in linear algebra where the rows are multiplied by columns, matrix application or multiplication in Python is very different. It's not that one. It's done by, it's element by element. So each element by this element, this by this. So to perform the conventional linear algebra operations or linear algebra matrix application or multiplication, you use the dot function, which is not the scope of this video. So that marks the end of this tutorial. Feel free to subscribe, like the video, and if you have questions, drop in on the comment box, and I will try to help you with that.